Great, now you know all the core concepts of how to build a pipeline in GitLab CI/CD, and we have a structure of a CI/CD pipeline. In the script sections, or the main logic of the pipeline, we're just echoing some stuff. And of course, in real projects, we will be building and packaging an actual application written in some programming language and actually doing stuff like building an image, pushing and deploying that image to a deployment environment, and so on. So that's exactly what we're going to do in the next sections. So using the knowledge that we've gained in the previous sections, we're going to build a real-life deployment pipeline for our demo application. So let's see exactly what we will be configuring and how. So we will be using this Node.js application and building a complete real-life pipeline for it, which is going to have the following steps. First, we're going to run unit tests for the application, which are the simplest tests that basically just test the code itself. We're also going to run what's called static application security testing, which is basically scanning our code for any security issues. And we're going to learn all about different types of testing and how to do that when we get to that point. We're also going to build a Docker image from our application using the Docker file we have here. We're going to push that image to a Docker registry that GitLab actually provides. So we have a built-in Docker registry in GitLab for each project. So we're going to use that. And once we push that image, we're going to deploy it to a development server. So for that, we're going to create another simple EC2 instance on AWS, and we're going to use that as a development server to deploy and run the image that we built for our application. Once we have the image running on development server, we're going to see how to promote a new application version to staging or test environment and then to production environment. So we're going to build this whole automated CI/CD pipeline with all these steps for this Node.js application. But we're going to do that step by step. So in this chapter, we're going to start with the basic version of that pipeline. And this is going to include running unit tests, building and pushing the Docker image, and deploying that image to a development server. So that's going to be our first main structure. And as part of the real-life pipeline, we're also going to see how to increment and set the image version of our application dynamically in the pipeline instead of hard coding it in the code. And note that for the whole demo, we're going to use the free version of GitLab CI/CD to build this whole thing. So as a first step, let's actually see a little bit overview of our Node.js application and what's inside, and also what does this application do. So I'm going to clone it and run it locally and basically show you the UI of the application. So copy the clone URL. So in my GitLab CI/CD folder, I'm going to do git clone and the git URL of my project. And if we go inside, we have all the files here. So we have the code locally. Let's actually open this application code in Visual Studio Code to have a better visualization. If you don't have a Visual Studio Code, you can use any other editor, or you can simply download it. It's free and it works perfectly for any JavaScript application. So I'm going to open my Visual Studio Code. Let's close this and let's actually open this project. And make it a little bigger, and there you go. So now we have our application code in the editor. We have the GitLab CI YAML file, which we can edit here as well. We have our Docker file that defines how we build the Docker image of our application. And this is where the whole code is located. It is super simple. We have this index.html, which is basic CSS and just static content here. We have some images for nice visuals. We have the server.js, which is just starting the application in the background on port 3000 and also sending the images. And we have, for any application dependencies, we have package.json that defines them. So we're using Express for our application that basically starts the server. So these are our dependencies, super simple. We also have 3 tests for our application, and these are going to be our unit tests. So I basically added very, very simple logic that simply checks that we have an index HTML file and Docker file and git ignore file, and that's it. So if we accidentally removed any of those, it will fail. So that's basically the test. And the test is also using some libraries. And for that, we also have dependencies. We're using jest and jest JUnit dependencies. So if you don't know Node.js that much, don't worry about it. This is really, really simple logic. We don't have to go into detail or understand it. We want to be able to basically build it into a Docker image and then deploy it to the server. Right here we have what's called scripts. So basically using npm commands, we can execute them. And we have 2 of them to run the application using npm start. That's what we're using in the Docker file, right? So the application has to start inside the container. So that's the start script that basically just runs the server.js file. And we have another script, which is test. So this will run all the tests defined here. And it is using this jest. So usually you can write tests with different frameworks, right? So each programming language has multiple frameworks with which you can write tests. And for JavaScript, it's jest. And we have these options here that we're passing to our jest command that basically generates test reports for us, right? That's what these options are doing. It tells jest, run the test and then give me a report of how the test ran. What was the result? How many failed? How many succeeded? Etc. And the reports can be generated in multiple different formats, and we're using a JUnit format. Again, we're going to see that in detail when we're actually running unit tests in our pipeline. For now, let's actually run the application locally to see the UI and execute the test locally to see how it looks like. So I'm going to open a terminal and to run the application, just like we have defined it here in Docker file. So to start the application, we have to run npm install and npm start. That's it. However, know that we have to be in app folder to run those commands because this is the folder where the package.json is and all the application files are. So we're gonna move to that folder. That's a very important step. Do not miss that. So in the app folder where we have our package.json, server.js, tests, and so on, in this folder, we're gonna do npm install. This will check all the dependencies defined here and will just fetch them from internet, right? From the npm repository. So let's execute. And you see node modules folder was created and those dependencies were installed. So we're good to go and to basically start the application. npm start, this will execute the script defined here, which is node server.js. Let's do that. There you go. So we just started our application on port 3000 locally. So now if I go to browser and do localhost 3000, there you go. We see the UI of our application, and that's the index HTML that we have here. So we have this static HTML code with 2 images, and that's what we're seeing here. So that's how the application looks like. That's what we want to deploy on a development server. And now let's also see how to run tests. So let's stop the application, Control C. And let's run the tests, which is npm test command. Like this. And you see the command that we have defined here was run. And we have an output that all 3 of our tests passed. So everything is green. And since we're generating these JUnit format reports, test reports, when we run tests, we see that this junit.xml file was generated that basically includes the test results in machine readable way, right? So we have the test case, whatever we defined, and we have the results like no failures and so on. And that's it. And we can also exclude the junit.xml file from the repository because we don't want to check that in. And if I save, you see that it becomes gray. So it's being ignored by Git now. So .git ignore, if you don't know what it does, it basically gives you a way to exclude any generated files from being pushed to the remote repository, right? So each developer will have their own copy of node modules and junit.xml. They don't have to be in the remote repository. the packaged log JSON should be checked in. And that's why you see the color highlighting. These gray stuff are basically just ignored. You will have them available locally, but they will not be checked in to the remote. So let's actually add those changes and commit them. And push them to the remote. And note that for adding those changes, you have to go to the root directory again. So go out from the app folder. And once we push that, we should see the changes here. So that's our project. And we want to build this application and deploy it on an EC2 server using the GitLab CI/CD pipeline. So let's start with the first step, which is running unit tests. So those 3 tests basically that we have defined. And you can have hundreds of unit tests for your application. The more complex it is, obviously the more tests you will have. So we want to run them first. So let's go to the CI/CD pipeline and editor. And let's actually clean all this stuff up. So I'm going to remove the image. Let's leave the workflow. So this pipeline will only run either for main branch or for merge requests. For all the feature branches, it will be ignored. And we're gonna delete all of it. And we're building our pipeline from scratch. So first job will be to run unit tests. And we're gonna run these unit tests on our self-managed runner, which has a Docker executor. So let's provide the tags. So it's EC2, Docker, and remote. So we're going to run the unit tests inside a Docker container. The script for executing the unit tests will be npm test, just like we did locally, like this. However, you remember that before we were able to do npm test or npm start, we had to first change to app folder, because that's where we have the test, and that's where we have the package JSON that has this test script. And we also had to do npm install first, because we need the dependencies for the tests so that they can run. So these 2 things need to run before we run the tests. And we can include that in before script, cd app, and npm install. And this will execute our tests. Now, since we're using npm commands, we also need to have those npm commands available inside our Docker container, right? So we're going to use an image that has npm command inside. So we're going to define image, node, and just go and grab the latest node image. I'm going to use this one, and that's it. So we're executing our unit tests using npm test command inside a Docker container with node image. So let's actually test this. Commit changes. We only have 1 job and 1 stage, so that's the only one which will get executed. And let's refresh, and there you go. So the job is green, which means the tests were executed successfully. Let's actually see the logs. So we have cd app npm install inside the node container, and this is where the tests were run. So we see in the logs 3 tests passed. We have no failed tests. So that's fine. However, we only see the test results inside logs of the job. So we have to go inside the job and see those logs. But we don't have an overview of the test executions inside the GitLab UI, right? And you see we have this test tab here, which is empty. And it says there are no test reports for this pipeline. Now, you remember that in our package JSON, we actually have an option that generates reports for our tests in junit.xml format. However, we don't see any reports here. And also, in the list view of the pipelines, we have no artifacts for the test reports. So how do we use those test reports that we actually generated using Jest to show them in GitLab? Or basically, how do we make GitLab use those reports and visualize them for us in the UI. Going back to the editor, we can actually configure our job to use the unit test reports that Jest generates for us so that GitLab can display it for us. And it's actually very easy to configure. For that, we have an attribute called artifacts. Inside the artifacts, we have reports, and we have the format of reports. And there are a couple of formats, and we're going to use JUnit format and specify the generated JUnit file that Jest gives us. So junit.xml inside the app folder. So it's going to be app/junit.xml. So the way it works is that JUnit report will collect the JUnit reports from XML files. Those collected unit test reports will be uploaded to GitLab as an artifact. That's why we're using the artifacts attribute. And then GitLab will be able to actually visualize it for us and display it in its UI. Now, maybe interesting to note that JUnit was originally developed in Java. However, there are many third-party libraries to generate JUnit format test reports for other languages like JavaScript, Python, Ruby, and so on. And the Jest JUnit library is actually the one that lets us generate the JavaScript test reports in JUnit format. So that's just as a side note. And also note that the reports must be in XML format. Now we want those reports to be uploaded as artifacts, not only when the tests are green or they pass, but also when the test fails. And for that, we need to add a condition to say when, always. So even when tests fail, please upload those reports to see the failures of the tests. So with this configuration, we should see test reports in GitLab UI as well. So let's commit, view the pipeline, and if we refresh, we see that test execution is green. And here, instead of 0 tests, we have 3. And inside that, we have this visualization that actually came from the test reports. So we see a list of jobs that executed tests. And if we click inside, we see a list of tests for that job. It shows us the name of the test and the duration. And also in the list view of the pipelines, in the artifacts button here, it says artifacts. If I click here, we see we have an artifact that we can actually download. So this is going to be our junit.xml file. So we see this junit.xml file, which is zipped. So that's basically it, right? The same thing we saw in our JUnit file, basically that contains the test results. So this is the file that GitLab uses to generate this type of UI overview for your tests. Now, if you want to make your test reports, the downloadable test reports, browsable, so basically the folder structure and everything, we can add an additional attribute here called path, which is a list, and basically add our JUnit report there. And obviously this will make sense if you have multiple test reports that you want to kind of organize and not have them all in one place. So let's see the result of that one. Commit those changes. In addition to that path attribute, let's also make one more change, and let's fail one of the tests on purpose. So basically in the server test.js, I'm simply gonna change this to be falsy. So the opposite, which should fail. Commit that. And let's see our pipeline. So this should actually fail one of the jobs, and we will see that in the test reports as well. And there you go. And here we have a failed job this time. Let's see the test reports. First of all, we have the success rate. So from 3 tests, 1 of them failed. If I click inside, also see the status here. And additionally, you have this failed jobs tab, if you notice, that also basically describes what exactly failed in the job. And in the list view of the pipelines, we should see that additional artifact that was generated using the path attribute. So that's the JUnit one that we downloaded before. Now let's actually see what's in that other artifact. And if I open that zipped folder, you see that it basically has a structure. So you have the app folder, and inside that you have the junit.xml. So this one basically just gives you a more browsable structured artifact of your reports. And as I said, this is more relevant when you have multiple different reports with the hierarchy and so on. So you can use that as well. And now let's see one final interesting thing in terms of how GitLab uses the test reports in this whole application development lifecycle. So let's say a developer is working on the code, they create a new branch. Let's say the developer wants to refactor some stuff. So let's call this refactor. And they're basically changing the code, cleaning it up and so on. And while cleaning up the code, they accidentally deleted the Docker file. So let's go here and delete this. And now that they are done, they want to create a merge request. So they didn't notice that the Docker file was deleted. Maybe while doing some merge, they unintentionally deleted this Docker file. So the test that validates whether Docker file exists will actually fail, right? So the developer now is done with the refactoring and they want to create a merge request. So let's create that. Now let's call this did refactoring. Let's leave everything as it is and let's create a merge request. So now another developer can actually review that merge request and see the status of it. Now let's wait for the pipeline to run. It is on pause currently, right? It is in progress. So let's wait for that to be done and see what happens with our failed test. And know that our pipeline logic is set to run when we make changes to the main branch or on merge requests. So that's why it automatically triggered a pipeline when we created a merge request. So let's wait for that pipeline to complete. And if I refresh, there you go. So first of all, we have these tabs here that says what we committed, the pipeline that ran for this merge request and its status, which is a failure, and the changes that we made, right? And in the overview, we have the pipeline status here, and we have something interesting right here. It says test summary contained 2 failed out of 3 total tests. And if I click on expand, I see a description of those failed tests. So these are the names of the tests that failed. And this one says that the test actually failed one time in main branch. So this is not related to the merge request. And this one is the new test failure that our merge request introduced. So this gives you actually a pretty nice summary or overview what tests are failing because of your merge request. And now another developer that is reviewing your merge request or you yourself can actually see what tests failed because as a result of your merge request, so you can go back and fix that. And you can also see the details of the test failure. If I click inside, it basically tells you exactly what happened and what the error was. So that's another interesting feature that GitLab gives you in terms of the test reports in your pipeline. And now, of course, you would fix those tests and so on. In our case, let's actually just close it. And that's it. So that's how you can run unit tests in your CI/CD pipeline for a Node.js application. So now we have one job that runs unit tests and let's say validates the code is correct. And once the unit tests are successful, we can build the application into a Docker image and then push that image to a Docker registry. So let's do those 2 steps next. First of all, let's go back to our tests. And let's fix that one test that we broke. So change it back to truly. We ignored the merge request, so we still have that Docker file. So now our test should be fine. And in our pipeline, we're gonna add 2 jobs, one for building an image and one for pushing that image to the registry. And as I said, GitLab actually offers a built-in Docker registry for every project, which is really good because you basically have everything in one place. And since GitLab actually wants to become the DevOps platform, so basically a platform where you build your complete workflows using the GitLab services and the best practices of DevOps, it gives you all these things out of the box or built in to your project. So before we write those jobs, let's actually check out the Docker registry that GitLab gives us. So here we have all the stuff that GitLab provides us with, and one of them is packages and registries. So let's open this in a new tab. And as you see, under these packages and registries, we have 3 types of registries. We have the package registry, which is for general purpose artifacts like zip files or jar and war files and so on. So depending on the programming language and the tools that you're using, you can create those packages and push them here for your project, and they can be used maybe by other projects as dependencies or whatever. Then we have the container registry. This is the one we're interested in. So this is where we can push all the images that we built for our application. And currently it is empty. We haven't built any images and pushed them here. And right here you see the commands to log in to that registry, to build an image and push it here. So one thing to understand about Docker registries is that you have public Docker registries like Docker Hub, for example, where you can get all the images and access them without any credentials. Anybody can pull and download images from there. However, if you're a company and if you're building your own application images, obviously you don't want other people to have access to those, right? So you have private registries for that. And in this case, you have a private Docker registry for your application on the application level. And in order to access any images inside that registry or to push images to that registry, you need to authenticate first, right? So you have to do Docker login with some credentials, and now you can access, pull and push images from that registry. Also, another thing about registries and how to push images to a registry is that the destination or the registry location where you want to push that image is actually in the name of the image itself, right? So when we build and tag an image or give it a name, so to say, we include the registry address or location in the image name like this. So Docker knows to which registry it should push that image. So for every GitLab project, it will have its own registries. And the name of the registry, Docker registry for your application will be registry.gitlab.com, your GitLab username, and the name of your project, right? So it's my node app CI/CD project. So that's the name of my image repository. And we also have a third type of registry that GitLab provides us with. This may change, they may add new ones in the future, but currently we have these 3. An infrastructure registry is basically a private registry for infrastructure as code packages. And in this case, specifically for Terraform. So you can write your own Terraform modules for infrastructure provisioning, which is related to this project or application, and you can host them here. Again, not relevant for this course, but just good to know that these are available. So going back to the Docker registry, these are the commands that we're gonna use in our pipeline. And one note about securing your container registry is that when you have a private project, only members of the project have access to that registry. So you can basically manage the permissions and access to your Docker registry based on the access for the project. And if you make the project public, then your container registry also becomes public. So as a first step, we're gonna build a Docker image for our application. So let's go ahead, write a job that will build our image. So we're gonna call this build image. And this will actually run on our managed GitLab runner, but this time with the shell executor. And remember, we have installed Docker on our GitLab runner, so we have Docker command available there. And then we have the script, which will build the Docker image. Now note that for building an image, you don't need to log into the registry. You can just go ahead and build and tag your image locally to whatever name you want. We're gonna need login to push an image. So I'm gonna copy this command and paste it here. And this will build a Docker image with this name. But we also want to add a version tag for our image. So we're going to do colon and 1.0. So that's going to be the version of our image. And then we have a dot, which is the location of the Docker file that will be used in order to build that image. And going back to our code, we have this Docker file in the root folder. So we don't have to change to app folder. It is in the root directory. So the dot current location of the root directory is fine. And inside the Docker file, we are basically using the base image, which is Node 16 Alpine. You can choose the latest one, whichever version you want. Then we're setting inside the container, we're setting the work directory to this location. We're copying the package.json and package.log.json, both of these from the app folder inside the working directory in the container. Then we're doing npm install. So the node modules get installed. We're copying the code into the image, exposing port 3000 and starting the application using npm start command. So really basic Docker file that basically copies everything from the project into the Docker image and starts the application using npm start command. So this Docker file will be used to build the image. And once we have that image, we can then execute push image job. Now we can do both in one job, but you can also split it. So in this case, I'm actually splitting and making it into two jobs. It doesn't really matter. And I'm also executing these on the same shell executor on our GitLab runner. And in push image, we're pushing the Docker image that we built to the repository. And again, don't forget the tag, the version tag, and there you go. However, as I said, before we push to a private registry, we need to authenticate using Docker login. So I'm going to copy this login command and we're going to do a before script, which does Docker login. And that's our logic. Now, let's introduce the stages again, because now all these three will run in parallel, which we don't want. So instead, we're going to define stages here. So we're going to have a test stage and build stage. So let's add those stages here. Build image in the build stage and push image also in the build stage. However, we want the push image to wait until the build image job gets done, because we can't push an image that we haven't built yet. So these two should not run in parallel. And that's why we're gonna do needs and build image. There you go. Now there's one more thing that we need to do here on the Docker login command. So whenever we're logging into a private Docker registry, in this case, GitLab's registry, we need to provide username and password credentials, which is logical because we need to authenticate ourselves. So where do we get credentials for our private registry? Because we don't have that on the commands here. You actually have multiple ways to authenticate. One of them is username and password. Another one is personal access token. In our case, we're going to use the easiest way, which is username and password. So where do we get those username and password for our registry? Where do we see those? Well, another cool thing from GitLab is that in a CI/CD pipeline, GitLab actually provides temporary credentials, username and password, for our container registry through environment variables. So we actually have the username and password for our private registry available inside the CI/CD pipeline using those predefined GitLab CI/CD environment variables. And if you remember, we have this predefined variables list where we can see different values that GitLab makes available within the pipeline, and the registry user and password are basically on that list as well. And in the description, you see that this is a username to push containers to the project's container registry, and you have a corresponding password. And this is a really good concept in terms of security the way GitLab does it, because the way it works is that GitLab will generate those two and make them available only for that specific pipeline execution or the job execution. You see that here as well is valid only as long as the job is running. So even if the password gets leaked, it cannot be used again, right? So we're going to use those two variables as credentials in our Docker login command. So in Docker login, we have those options, -u for username, and this is going to be registry user. Remember, we reference the environment variables using $sign, and then we have the password, which is registry password. There you go. And with that logic, we can now execute our pipeline, and this should build an image and push it to our project's container registry. So let's commit the changes and see what happens. So our pipeline executed and all the jobs are green. You can check the logs to see what exactly happened. Let's see the push image logs, for example. So we have the Docker login command, Docker push command, and all the layers of the image have been pushed. Now, if we go to the registries and container registry, instead of an empty list, we should see one image that was pushed. And if I click inside, we have this version or tag 1.0. So this is our image. And if you want to pull that image, you can grab the full complete name of the image, including the tag, using this button here. If I click inside, this is basically the whole image name. So we have the registry, which is GitLab's registry, my username, the project name, and the version tag. Awesome. Now let's do some optimization to our pipeline. Let's go back to the editor. And right here we see that we're using the image name in two different places with the image tag, and it's hard-coded. And we also have the registry name, which is also hard-coded. And we don't want those hard-coded values. Instead, we want to dynamically get the name of the image repository and reference it here. Well, if we go back to those predefined variables list, we have two other variables for the registry. One of them is the CI registry itself, which is actually this value. So the general address of the GitLab registry. So we can reference this as a variable. And the second variable we have is the image repository name. So this is actually the value, the complete value of this, right? So the GitLab registry URL plus your GitLab username and project's name. And we can use that variable to reference the value. So we don't have to hard code it. Do the same here. And just to make sure, let's actually print out the values of those variables. Docker registry URL is let's also print out the registry user that gets injected and Docker image repository. And let's reference it like this. So let's execute our pipeline again. So everything is still green, and let's go to push image logs and check those values that we echoed. So we have Docker registry URL. This is the value that we're referencing with this environment variable. Then we have the registry user, which is GitLab CI token. So that's the username for the repository, and that's our image repository that we had hard-coded before. So all these values are injected by GitLab into our pipeline, so we can reference them using the environment variables, so we don't have to repeat them or hard-code them in our pipeline code, which is really great. Now, there's one more thing to understand in terms of the image hierarchy and how images are actually pushed to the repository. So right now in the registry, we have this URL that has the project name, and then we see something like slash and root image after that. So what is that root image? Or why do we have a root image in the URL? Well, this means that in our container registry, we can have multiple image repositories. And for each image repository, we can have multiple tags or versions. For example, so we may have a project that builds multiple applications, like a microservices applications, for example. And each microservice application will have its own image repository name. So we may have my node app CI/CD project / payment service, or / user authentication, or / shopping cart, and so on. So instead of having everything in root image, which is the main bucket, so to say, or main space for all the image tags, we can have multiple image repositories, and each one can have its own tags. So root image is the global level where all the image tags will be pushed. However, as we saw before, if I copy this URL, it will not contain the root image, obviously, in the URL. It will just contain the name of the project, and then we're gonna have a tag like this. So now let's say we actually want to give our image a hierarchy and give it some microservice specific name. So instead of the project name, we want to do something like microservice payment, for example. So we want this to be our full image name, and this is going to be the tag. How can we do that? Super easy, actually. Let's go back to our pipeline. And right here, we're simply going to append whatever we want, right? So I'm going to copy this. So we're going to do microservice payment. So we're building this image here, and we are going to then push that same image in Docker push. So let's see what happens now. Let's commit those changes. All right, so our pipeline ran. Let's go to container registry and let's check our image. So you see that a new URL was generated, or new image repository was added with a name that we defined instead of root image. And inside that we have this one tag. And again, if I copy this and paste in here, that's now the full name of our image. And now we could even parameterize the name of the microservice and pass it as a variable reference, for example, instead of hard coding it here, and create and push to a different image registry based on which microservice we're building. So let's say this is a microservice placeholder for microservice, like this. And let's do the same here, instead of the payment. Now I'm going to commit the changes, and let's actually, which will trigger the pipeline, but let's actually cancel the pipeline because we have to define the value of that microservice variable, right? So the pipeline is canceled. And we're going to trigger run pipeline manually. So if I click on this, it will show me that it's building a branch main. And here we can actually pass any variables that we want to our pipeline. So I can do microservice. So that's the variable that we defined in the pipeline, and I can set it to, let's say this is shopping cart. So we're passing this environment variable with shopping cart value, and let's run. And that's actually another way to pass in variables in a flexible way to your pipeline as an alternative to defining them globally here in the settings, like we did before. So going back to the pipelines, it is in progress. So let's wait for that to finish. And let's check the push image logs. And this is a new image repository with shopping cart at the end. So in the container registry, now we should see another image repository with shopping cart in the name. So that's how you can use your container registry for one project to build multiple images with different names, each one having its own tags. And let's do one final optimization to our code, because now we have this a little bit more complex image name and we're repeating it in 2 different places. Could be that we change something later and we forget to adjust it. So what we can do is we can take this whole image repository name and we can put it into a variable. So right here, let's define variables. And let's do image name, which we put together using those values. And let's also have image tag defined here. And it's going to be 1.0. And now we can reference those variables in our pipeline like this. Image tag, and there you go. And we don't need those echo commands. And let's actually push another tag so we see a second tag for the image. And we would need to pass that microservice value again to our pipeline. So let's do that. Let's actually cancel this one. Let's do shopping cart again. And let's see. So obviously triggering the pipeline manually and passing the variable is not convenient when you want to trigger them automatically, but we're just doing it for this example. And for the last time, let's check the container registry. And in the shopping cart image repository, we now have 2 tags, 1.0 and 1.1. So that's how you work with container registry in GitLab and how you push Docker images from the CI/CD pipeline to your project's container registry. At this point, we have a pipeline that runs unit tests. It builds an image and pushes that image to GitLab's Docker repository. And once we have that image available in the Docker registry, we can actually deploy it to a development server. So that's what we're going to do in this video. First of all, let's clean up our pipeline and let's actually remove this part because we don't have a microservices application. It's just one application. So let's just leave the name at the simple, say, registry name. Let's still keep the variables, image name and image tag to make it easier to read and maintain and maybe update it later. And right here, let's add another job called deploy to dev. So that's going to be our next job. So what do we need in order to deploy our Docker image that we build and push here to a development server? Well, first we need a development server, right? Right now we have a GitLab runner on our EC2 instance. And let's actually tag our GitLab runner instance. And now let's create another EC2 instance, which is going to be our deployment server for development environment. So let's do launch instance. Let's choose Ubuntu server. We'll choose all the defaults, review and launch. And we're going to create a new key pair for this one. Let's call this dev server. Dev server key. I'm going to download this key pair because we need the private key available to be able to SSH into it. And let's launch the instance. So now we have a second instance, which is going to be the dev server. And let's actually give the name as well. So it's going to be dev server. There you go. Now on the dev server, when we deploy the Docker image, and run it as a container, we need to have Docker available, right? Because we need to be able to run Docker on it. So what we're going to do is we're going to SSH into our dev server and we're going to install Docker on it. So going back to our terminal, we have this dev server key, which we can use to SSH into the dev server. But as you remember, we have to secure or restrict access to that key first. So let's do that. Change mod. Dev server. Let's limit the access permissions. And now we can SSH to our instance using that private key. And the username is going to be Ubuntu. And let's grab the public IP address. Yes. And we're inside our dev server. Now if we do Docker, you see, we get the installation command. Let's copy that. Let's first actually do sudo update, sudo apt update. There you go. Now let's install Docker. Great, so we have Docker installed. However, we cannot do Docker PS yet because we need to give our Ubuntu user the permission, which is permission to execute Docker, which we do by adding the Ubuntu user to Docker group. And we do that using sudo usermod command, add to the group called Docker, user called Ubuntu. And if we log out and log in again, Ubuntu user should be able to execute Docker commands. Awesome. That's all we need on the development server in order to be able to pull the image from our GitLab private repository and then run that image as a Docker container. So let's exit from here. Our job is done. And go back to our GitLab configuration. So we have the development server. It is ready and waiting for GitLab to deploy Docker application. But now the question is, how do we connect from GitLab pipeline to the dev server instance? The way we did it locally is we basically SSH'd into it using the private key, the name of the user, which is Ubuntu, and the public IP address, right? So we need this information so that GitLab can SSH into the dev server, just like we did locally, which means we need to provide GitLab the private key that we have available. So let's go ahead and do that. How do we provide GitLab a private key of a server? Pretty easy, actually. We go to settings of the CI/CD, and in the variable section, we're going to create a secret variable, so to say. So let's do add variable, and let's call this SSH private key. And the value will be the contents of the SSH private key file. So you can basically print out the contents like this, copy the whole thing until the percentage character, we don't need that one. So copy the whole thing and paste it in here. We're going to leave the protect variable checked. And here's one interesting thing. So protected variable means that it's only exposed to protected branches or protected tags, like the default main branch, for example, and not the feature branches. And we also have another check for mask variable. And this is actually something that you should check for any secret data, like a private key in our case. And the way it works is that it lets you use the variable in job scripts without the risk of exposing the value of the variable. So if someone tries to output it in the job log with a command like echo the variable name as a reference, the job log will only show the echo masked output, which is something we want for secret values. However, there is a limitation in GitLab when it comes to the private keys. And it means that we cannot mask variables with these values. And that has to do with the fact that mask variable has some strict rules about what type of content you can mask. And it is kind of a known issue or known limitation of GitLab, we can't really work around that. So we're gonna have to leave this unmasked. So I would say there is a room for improvement, and maybe this is gonna be fixed or improved in the future, but right now we cannot actually mask it. However, just note that whenever we're using secret values, so if this was a password or a token, we would actually mask that. So now, because of the limitation, we're gonna leave it unmasked. And finally, we're gonna change the type of our value to a file, because we want our private key as a file, so that we can pass it like this. And let's create our variable. So now we have that private key available for GitLab in the pipeline, and we can use that to SSH into the dev server. So going back to our pipeline, let's actually write the script that will SSH into the dev server, like we did locally, then does docker login in order to be able to push the image from the GitLab's private repository and then run the image as a Docker container. So let's do all of that. So deploy to dev, let's add a new stage, deploy, right here. So we're introducing a deploy stage, and deploy to dev will be executed there. Let's also execute it on our GitLab runner with shell executor, and the script will be the SSH command. And in our SSH command, we're gonna reference that private key. And as we learned, for a file type, when the runner makes this variable available in the environment where the job is running, it will actually create a temporary file and write the contents of this variable to that temporary file and store the path to that file's location as a value. And we can reference that file path using this variable. So that will basically reference our private key file, the temporary key file. Then we have our Ubuntu user and the public IP address. And again, if we don't want to hard code it, we can reference it as a variable. Let's call it dev server IP or host. And dev server host will have this value. Again, it's nicer to have all the variables in one place so you can change the values if you need to and just reference them throughout your pipeline logic. So we have the private key, we have the user, we have the IP address, and one thing we need to add as well is disabling the strict host key checking. So this basically refers to this prompt right here. Whenever we connect to a server for the first time, we get this prompt that says whether we want to confirm the authenticity of the host on our side. And in our case, we have to type in yes and so on. But since our pipeline is running in non-interactive mode, so we're not going to be entering some values there, we want to disable this check and just say skip that. So that's what we're going to do here, and this is going to be strict host key checking equals no. So that will take care of it. And with this command, we're going to be SSHing into the dev server. And once we SSH into the dev server, obviously we want to execute the Docker commands, right? How we do that? Also very simple. We're going to pass those commands as parameters to our SSH command. And we're going to put them within the quotes like this. So first, we're going to do the Docker login on that host, and we can actually reference those same variables that we have here. Super easy. So again, note, this gets executed inside the GitLab runner, and this gets executed on the dev server because we need to pull the image from the private repository, so we have to authenticate. And since we are executing them as shell commands, we're going to do end here so that we can write the next command, which is going to be docker run. So once we authenticate it with the private registry, we can now pull the image and run it on the server. So let's run it in the background in a detached mode. That's what -d stands for. We also need to expose the port. So we're going to bind port 3000 on the host to port 3000 in the container. Because if you remember, our app starts at port 3000 and we need the image in this registry, right? Which we can reference like this. So it paid out to parameterize all those values because we're using them in a lot of places. And it's good that we're not hard coding them. So that's basically how we're going to deploy our Docker image to dev server. Pretty easy. We're SSHing into it the same way as we did locally. We're executing docker login and docker run commands, and that's it. So let's execute our pipeline and see what happens. And we see that our pipeline actually failed. So let's see what the issue is here. In deploy stage, in logs, we see that the key is to open. So we have to limit the permissions to the key just like we did locally, right? So for that key, we basically executed this command. So we are getting the same warning here. So let's go ahead and fix that. And the way we can do that is we can add a before script here that basically executes the same chmod command for the temporary file, like this. And let's commit the changes again. And our pipeline is green, so the deploy build was successful. Let's check the logs again. And as you see, Docker login was successful and we were able to pull an image from our GitLab repository to that dev server to run it as a container. So now, if we log in to the dev server and do docker ps, we should actually see our container running. This is the image with the tag 1.1. because that's what we specified here, and it is available on port 3000. So now let's actually access this application from the browser. And for that, we're going to go to our dev server instance. First, we're going to make sure that the security group of that instance allows access on port 3000. So let's go to security, security group, edit inbound rules. And we're going to add a rule that will allow access on port 3000 from any source. And that's it. Let's go back to the instance. Let's copy either the public IP address or the public DNS. So let's take the public DNS, type it in the browser, port 3000, and this should display us the application, which is the same application as we have here. So we have built and deployed our image successfully on an EC2 server using our GitLab CI/CD pipeline.